Welcome to MathLink, where we connect the dots. I am Mr. C, and in this lesson, we're going to go over something that's very important in the trig. We're going to introduce trig functions. And so this is a video that's going to be your foundation for other videos that's going to talk about trig functions such as sine, cosine, tangent, cotangent, secant, and cosecant. So let's get started. So identifying the sides of a right triangle. So we're going to focus on the right triangle and use our different trig functions to get different values. So let's get started with how it looks. The sides of a right triangle are named. We have the opposite side, the adjacent side, and the hypotenuse. So a triangle had three sides, but with respect to a certain angle, there's an opposite side, adjacent side, and a hypotenuse. The hypotenuse is the longest side of a right triangle. Remember, a right triangle is a triangle that has 90 degrees, and the side that is opposite to the 90 degrees is the hypotenuse, and it's always the longest side of a right triangle. The position of the opposite and adjacent side depends upon the reference angle. So some side could be an opposite to one angle, but it could be adjacent to the other. So upon the angle or the reference angle that is opposite or adjacent. The opposite side is opposite to the reference angle. So wherever angle it is on the right triangle, the opposite of that angle, that side that's opposite, is the opposite side, and the adjacent side is next or touches that reference angle. Now, let's look at these two triangles and look how these concepts work with these right triangles. The two right triangles below each have their sides labeled according to a given reference angle. So for the first one, we have angle A. I'm going to call that angle A. So if this is our angle we're looking at, so you got to stay with the reference angle, then the opposite side will be this side, according to that angle A. And then the adjacent side will be the side that's touching that angle, which would be here. Now, the hypotenuse is always going to be the side that is opposite to the 90 degree. So that's that particular drawing. Now, depending upon where the angle, our reference angle, let's look at the second triangle. So let's look at angle B. With respect to angle B, the opposite side is over here. With respect to angle B, the adjacent side is this one, and we already see where the hypotenuse is located, opposite to the 90 degree angle. So it's always respect to the angle that is an opposite or adjacent side. Now, these are three functions. Again, here we go with the big three. So the big three that we talked about, if you know the big three, then the other three trig functions come from the big three. So know these, and this will help you out with the other trig functions. So these are big three, or you should know these by heart. Sine, cosine, and tangent. And look at our symbol. This is how we abbreviate it. And if you want to know what that Greek letter is, it looks Greek next to the word sine. It is Greek. It's the Greek letter theta. So you're right, it's Greek. So in this case, we look at our sine function. I'm going to look at the first one. So normally we write it like this, the sine of theta. So that's how you normally write it, sine of theta, or the sine of angle A. And if you want to write that, I write this on the side, you can say sine of A. And you usually put in parentheses so you know the sine is a function and it's acting upon a angle, okay? So that's how you normally write it, sine of A. And the definition, you need to know this by heart. This never changes. The definition is the opposite side over the hypotenuse. So sine is opposite over hypotenuse. Cosine of A is going to be, or cosine of theta, is going to be adjacent over hypotenuse. Adjacent over hypotenuse, and then the tangent of theta, or I could say tangent of A, if that's the angle we're looking at, is opposite over adjacent. So you need to write these down and put this in your memory. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. They both have the hypotenuse. The tangent is different. It's the opposite over the adjacent side. So as you remember these, this is going to help you out. Now, as we look at the other three functions, or let's look at this particular example, and I'm going to actually go back. I'm going to go back and I want you to understand that the other trig functions, the cotangent, secant, and the cosecant, and this is how we write it. When you write it, you want to write it like this. Excuse me for my diagram. Keep going to the next slide because I think it's excited to get to the example. This is how we write it. This is how we write cotangent, COT of theta, secant, that's how you say that. And then cosecant is CSC of theta, or you can say CSC of parentheses A. Now, the cotangent has a relationship with the tangent. I'm going to write that next to this in blue. And it's the reciprocal. So if the tangent, listen to this, if the tangent, I'm saying just the tangent, is opposite over adjacent, then the cotangent is adjacent over opposite. And this is the definition of the cotangent. It's reciprocal of the tangent. Now the secant is reciprocal of the cosecant. Definition of the cosecant is adjacent over hypotenuse. The definition of the secant is going to be hypotenuse divided by the adjacent side. And then this last one has a relationship with the sine, which is the cosecant. Now the sine again is opposite over adjacent. Then the cosecant is a reciprocal. It will be hypotenuse over opposite. So again, if you know the big three, the sine, cosine, and tangent, you know the other three because they are reciprocals. They just switch the numerator and the denominator. Again, put these in memory, know these by heart. I know there is an acronym, and so make sure you learn the acronym if you want to go that particular way. Now, let's look at this example, great example, trigonometric functions. The sides of the triangle below are labeled with different letters. State the ratio of each of the 6 trig functions in relationship to angle A. Angle 1. So here's angle 1. And we're going to start with sine, cosine. So always start with the big three to give you an idea. And so what you're going to do, so let me do one for example. You're going to use angle, here's angle 1. This is angle 1 right here. So you say the sine of 1 or angle 1 is equal to, and according to this right triangle, use the definition of the sine. The sine is what? The opposite side. So here's angle 1. The opposite side is S. It'd be S over the hypotenuse. In our case, our hypotenuse, will be M. So that's how you do the first one. That'd be the sine of angle 1 is equal to S over M, knowing where angle 1 is. And you want to do the same thing for the remaining 5 trig functions. So pause this, see if you can do cosine, tangent, cotangent, cosecant, and so forth, and see if you can get, and write it like this. The cosine of angle 1 is equal to those two letters. So do that for a second, pause, and let's see what answer you get, and we'll see if we get the same answers. So we did the first one. The sine of angle 1 is equal to S over M. Let's look at the next one, cosine. Now the cosine of angle 1 with respect to angle 1, just angle 1, would be the adjacent side over the hypotenuse, which would be L over M. Now the tangent would be, with respect to angle 1, would be the opposite, which is S, over the adjacent, which is L. Now let's do the other 3. The cosecant, which is the inverse of the secant, will equal or reciprocal will equal to M over S. The secant, SEC of angle 1, is M over L, and the cotangent will be L over S. So if you know the big three, you know the other three by just taking the reciprocal of what we learned from the first three. Although this may be a short lesson, please review this lesson. Please put all that I've taught you in this video in mind, so when you get to some more complex trig problems, you already know the definition of the trig functions. Again, look over this video, look at some of the supplementary material that we have on our MathLink website. And again, as I always said, let MathLink bring it together. Thank you for watching this video.